All right, so we learned about inverse properties of logs, and here we have 3 more properties of logs, and this looks like a hot mess. What is going on here? All right, so the first property tells you that you've got log base b of m times n multiplication, and this is essentially telling you that you're allowed to distribute this log to the m and to the n, but when you do, you get addition in between. All right, and then the second one tells you that you are allowed to distribute logarithms over division. When you do that, you get subtraction. And then the last property, which is a really helpful one, says that if you have an exponent inside your logarithm, that you can pull this down out front as a coefficient. Right, this example, I ask you to expand the log base 2 of 16x squared y. And this is just to get practice with those 3 new log properties and perhaps the earlier 2 inverse properties along the way. All right, so if I look at this, I've got a whole bunch of multiplication going on in my logarithm, which makes me think that I might be using this rule where I've got log of multiplication. But I need to think of this 16x squared y as an m times an n. So I'm going to pick 16 to be my m and x squared y to be my n. And when I do that, the property says that I can distribute that log base 2 with addition in between. So this will look like log base 2 of 16 plus log base 2 of x squared y. And now that you've split this logarithm into 2 logarithms, you can treat these 2 logarithms like completely separate problems. So you can use a property on one that you don't necessarily apply to the other. For example, the one on the right, I can do my log base 2 of m times n thing again, where I distribute that logarithm and then use addition in between. Log base 2 of 16, what I'm going to do here, I'm going to think about 16 as being 2 to the 4th. Okay, 2 times 2 times 2 times 2 is 16. All right, and I'm going to do that because my log property over here says that the log base 2 of 2 to the 4th, they're going to cancel out and just give me that exponent. All right, so log base 2 of 2 to the 4th cancels out and makes this logarithm just equal to a 4. The log has canceled out with the exponentiation inside. And then my second one, I'm going to use the m times n property. I'm going to distribute my log to the first thing plus the log of the second thing. And again, those 2 are just from that one logarithm there. All right. So I'm almost done. I have a 4 up at the front. There's nothing to simplify about a 4. On the right, I have the log of y. There's nothing else going on inside that logarithm, so I'm going to leave that one alone. And the one in the middle is where I'm going to use that third property that says I can take that exponent inside and bring it down out front as a coefficient. So I can bring down this 2 as a coefficient. So copy everything that we're done with, the 4 plus 2 coefficient log base 2 x squared, whoops, not squared anymore, x, and log y. All right, so now that all of my, oh, I forgot my 2 on my logs, 2, log base 2. All right, so now that all of my log base 2s just have single variables in the parentheses, there's nothing left to do with them, and this is expanded as much as I possibly can. All right, let's try another one of those. Here I've got a log base 5 of a fraction. So scanning through my red box, which has gotten rather enormous with log properties, I see this one here that tells me what to do with log of a fraction. And that's the biggest thing that's really going on in here. So I'm going to treat 25 a to the 5th like my m, and c squared is my n. I'm going to expand this into 2 logarithms, distribute it to the top, log base 5 of 25 a to the 5th minus log base 5 of c squared. All right, so again, looking at these completely separately, I know that in that second logarithm, I can take this 2 and bring it down out front. That's coming from that property there. And let's see, my log base 5 of 25a to the 5th, that's another m times n. So again, that's going to be this top property here, m times n. So when I distribute a log over multiplication, it gives me addition in between. So I'm going to say log base 5 of 25 plus log base 5 of a to the 5th minus, so those two came from that first log. And then the second log, I'm going to bring down that 2 as a coefficient, 2 log base 5 of c. All right, so now that last logarithm with the c in it is completely done. There's log of c, there's nothing else I can do to expand that, no more properties to use. In the middle, log base 5 of a to the 5th, I can do the same thing that I did on the last one where I bring down that exponent as a multiplier. And then log base 5 of 25, I can rewrite that as 5 squared so that my log base 5 and the 5 will cancel out and will leave me just with that 2 down on the ground. Okay, so I'm going to get a 2 here, bring down my 5 as a coefficient, log base 5 of a, minus 2 log base 5 of c. Right? And that's it. All right, last one where we're going to expand. This is the natural log of a fraction. So again, we're going to be looking at this middle property where x squared plus 1 is m, and then all of this mess down here is n. And remember that natural log is log base e. If you'd like to write this problem out using log base e, you can, or you can just use the shorter ln notation, which is what I'm going to stick with. So I'm going to say natural log of the top. Because we had division inside the logarithm, I'm going to have subtraction down here, natural log of the bottom. Okay. So the first logarithm, natural log of x squared plus 1, there's really nothing I can do for this one. I can't take this square and bring it down out front because that square doesn't belong to the plus 1 inside the parentheses. If I bring down the 2 out in front, then it's going to imply that that x plus 1 all was being squared and not just the x. So I can't do that. And there's no property down here that tells me what to do with log of m plus n, like where there's addition inside the logarithm. All right, so that one actually is done. There's really nothing I can do with log properties on that one, but there's a ton that I can do down on the bottom. All right, so this one, natural log of y to the 4th times root e, this is back to this top property here, where I've got natural log of m times n. So I'm going to distribute that logarithm to both of those. And since it's multiplication, I'm distributing with addition. All right. Hopefully that made you go, wait a minute, because I do have something wrong here. I do split up that one logarithm into 2 logarithms with addition, but the original logarithm on that middle line was being subtracted. So when I split it into 2 parts, I need to subtract both parts. So I actually should have had a big set of parentheses around that. And in the next step, I'm going to distribute that negative sign to both logarithms. All right, so I've got natural log of x squared plus 1 minus natural log y to the 4th minus natural log of root e. Root e, before I write that down, I'm going to write that as e to the half. I know logs do a lot with exponents, so we may as well rewrite any radicals we see as exponents. All right, let's see. We said we're done with the first logarithm. Now, natural log of y to the 4th, I can use that third property to bring down, or the bottom property to bring down the 4 as a coefficient. I could use the same property on natural log of e to the half, and that wouldn't be wrong, but there's actually a better thing I can do with that. All right, so take this natural log of e to the half up here. I'm going to write that as the log base e. That's what the natural log is. Log base e of e to the half. And see why I did this. Now I can use that inverse property here. Log base e of e to the whatever cancels out and gives me that this is just equal to plain old half. So that's actually better than using that exponent property that comes down as a coefficient. All right, so what do we have left down here? Natural log of x squared plus 1. The 4 comes down as a coefficient. And this one, we said we were going to simplify the whole thing to be equal to 1/2. And that's all we can do with that one. So one last thing we want to be able to do with these properties. And it is to go backwards. All right, so this is a log expression that somebody has expanded completely, and we're going to try to reverse engineer it and pack it back into a single logarithm. All right, so now you're going to be looking at the right-hand side of the bottom three properties and see what you can do. All right, so we do have addition and subtraction in those first two properties, which we can use in this case. But the first thing I want to do is get those coefficients back inside the logarithms as exponents. So I'm going to be using this third property here that says the a can go back inside as an exponent. So I'm going to bring the 5 back inside as an exponent in that log, and the same thing with this log. Okay, so we're going to have the log, and again, this is the log base 10. You can write it there if you want it there, but we all know it's there. X to the 5th, and then I'll have log of y to the 1/4, and then minus log of z. Right, so you have one addition and one subtraction. It really doesn't matter which one you mush together first using a property. I'm just going to go left to right. So I've got a log plus another log. That's going to be referring to this first property. So that tells me mush them together. On the left-hand side, it says you can mush them together. You just multiply arguments. So we're going to have x to the 5th times y to the 4th. And then this minus log z is just hanging out. All right, so now that you've done that, now you have two logarithms separated by subtraction. And we're going to use this middle property here. If you've got subtraction between your two logarithms, when you mush them together, you divide arguments. Okay, so I'm going to get the log of x to the 5th, y to the 4th, divided by z. All right, and now it's mushed together in one logarithm. It's condensed. I'm happy with this as an answer. The only other thing you could do is to rewrite that y to the 1/4 as the 4th root of y, and that's fine if you want to do that, or you can leave it as y to the 1/4. All right, that's it for log properties, and I'll see you in class next time.